Today we will discuss about path function, that is work. Work is a path function and any property that depends upon the path followed by the system is called path function, and work is a path function. And work is of two types, that is electrical work and mechanical work. Electrical work formula is del G equals to minus NFE, while mechanical work is also known as pressure volume work. It is also known as pressure volume work. Now, when we are discussing about pressure volume work, it means due to the increase in pressure or decrease in pressure, volume of the system may increases or may decreases. On the basis of that, work done on the mechanical work is of two types, further classified into two types, that is work done on the system or by the system. So as I told you, it is all about a pressure volume work. So we will discuss about a system where we can increase or decrease a volume of the system. Let us consider I am taking a cylinder which have a weightless, frictionless piston which can move easily upward or downward without any friction. So we will think that whatever the movement of piston will be there, that is due to the change in pressure only. Now consider this is the piston. As it is a piston, it has some external pressure and have some internal pressure. The condition is that the piston is weightless and frictionless. Now I have taken that it has a surface area, that is the surface area of the container is A, initial volume is V1, final volume is V2, change in length, that is dl. Now I have taken there is a pressure outside the system, that I have written P external, and some pressure is present inside the system, that is P internal. So there is two cases may happen, that the external pressure is greater than internal pressure, or P external pressure may be less than the internal pressure, or maybe another condition possible that both the pressures are equal. Now as I told you that the piston is frictionless and weightless, so it cannot move by itself. Whatever the movement will occur, it is only due to the change in pressure. For change in pressure, both the pressure should have different values. For that, one should be greater, another should be smaller. Now in case both the pressures are equal, there is no movement of piston. In that case, we will not study about this, we will study about first two conditions. Now first let us consider that the external pressure is greater than internal pressure. I am assuming that the external pressure is greater than internal pressure. In that case, the piston will move downward. until both the pressures are equivalent. Now consider this is your initial volume V1, this is your final volume V2, and the area of the cross section of this cylinder is A, and the change in distance by the piston is dl, and we can see the displacement of piston is decreasing, so it is minus dl. That's why I am giving this one is minus dl. Now we will calculate. We can see the movement of piston is due to the external pressure, as it is greater than the internal pressure, it will move downward, and it is called work done due to compression or on the system. As we can see, the volume is compressed to little one, that's why it is called compression, and work done on the system. Now we will calculate about this. We know that work is equals to force into displacement Similarly, pressure is equals to force upon area. So we can say that force is equals to pressure into area. Putting this value, we will find that work equals to pressure into area, and there is a displacement. Now, here we can write there is a change in small work, that is dW. Pressure, the work is done on the system due to the external pressure, that's the P external, into area that we have taken, that area is A. Now, displacement, I told you that the piston moves downward, so the displacement is decreasing, that's why we are getting it minus dl. Now, area into length is considered as volume, that's why it is change in volume, dv. Now we will write P external minus taken first into dv is equal to dw. This is our formula, that dw equals to minus p dv. Now we will proceed further. Taking integration in both the sides, we will find that del w is equals to minus p del v. Mathematically, we are finding that the value is negative, but according to IPAC, the system is gaining energy. So it is positive. Mathematically, we are seeing that it is minus P del V, but practically, when we are discussing about system, the system is gaining energy. Gaining means it is additive nature, that's why we are considering that it is positive. So always remember, work done on the system or work done due to compression is considered as positive, although its value is W equals to minus P del V. Now we will discuss about work done due to expansion. Considering the same cylinder, here I am considering this is the initial volume V1 and this is the piston, same piston, weightless and frictionless, and this is your final volume V2 Here it is the initially P internal and P external. Here we are considering that P external is smaller than P internal. As the internal pressure is higher than external pressure, the piston will move upward. That's why volume is increasing from V1 to V2 and the area of cross section from the cylinder will remain same. Now, the change in displacement is considered to be positive, that's why I am giving it positive dl. Now, what we knew that previously, that work equals to pressure into area into displacement. Now, we can write the little change in work is considered as dw. Pressure is due to the external and area is A. We are finding that there is a positive displacement of piston moving from lower level to higher level. This is called expansion. This is called expansion. That's why it is considered as plus dl. Now our formula becomes dw equals to plus pdv. Taking integration in both sides, what we will get? We will find del W equals to plus P del V. Now, for expansion or work done by the system, W found to be P del V. Now, it is work done by the system. When any work is done by the system should lose energy. As the system, according to IPSC, system is losing energy. So we can say, according to IPSC, system is losing energy. So we can say here work done is negative. So we have to remember, whenever there is a work done on the system, it is considered to be positive, and when the work done is by the system, it is called negative. Okay, this is all about work done on the system and by the system. Also it is known as mechanical work. Now we will discuss about internal energy. That is considered as U. What is internal energy? It is the sum of all types of possible energies stored in a body or in a system. Whatever the type of energy it is stored in a system is called internal energy. What it is? It is the sum of all types of possible energies stored in a system. Now let us consider a system contains initial energy, the internal energy U1, and it absorbs some amount of heat energy Q to do some work, that is W, as it is all going on in the system. That's why I am adding it, which is according to the definition of internal energy is equals to U2, final internal energy. So our formula becomes Q plus W equals to U2 minus U1. So we can write B del U equals to Q plus W. This is one of the formula. And we know that W equals to minus P del V. That's why Q equals to del U plus P del V. This is another formula. As I have taken W equals to minus P del V, it is means it is work done on the system. It is a X compression. Okay. So we can say that internal energy is a work done due to compression or the amount of heat absorbed at constant volume. So internal energy can be defined as, in another way, it is the amount of heat absorbed at constant pressure, constant volume. So we can say QP equals to del U. As I am saying that it is at constant volume, we know that W equals to minus P del V. It means 0. Remember, when I am discussing about at constant volume, so there is no work done is here. It means QB equals to del U. That we have to remember. Now we will discuss about characteristics of internal energy. First, it is the extensive property. Second one, it is a state function. As it is a state function, it should not depend upon the path followed by the system. So we can say it is independent of path followed by the system. Now, as it is independent of path followed by the system, we cannot determine its absolute value. We cannot determine its absolute value. Now, we cannot determine its absolute value, but we can determine its differential value. That is, we can say GU integration of that U1 to U2 initial internal energy, final internal energy, that is equals to U1 to U2, that we can write U2 minus U1 equals to del U. Now we will discuss about laws of thermodynamics, that is zeroth law. What it is saying, when two systems A and B are separately in thermal equilibrium with third system C, then system A and B are in thermal equilibrium. Now what does it mean? Consider I am taking water in bowl, 3 bowls with different temperature. Consider it is about 10 degrees Celsius, it is about 30 degrees Celsius, it is about 50 degrees Celsius. So we can see I got three systems A, B and C. They are and they have different temperature also. If I will place together, what will happen? As this has low temperature, this will gain energy from C. As it is greater than C, that's why it will lose energy to C. A will gain energy from C while B will lose energy to C. In this way, there will be a certain position where A, B, C should have same temperature. That will be near about average 80-90 by 3. It is around 30 degrees Celsius. I think it will all will get around 25-30 degrees Celsius in each case. This is all about zeroth law. Now we will discuss about first law of thermodynamics. It is also known as law of conservation of energy. So we know that what is the law of conservation of energy? Energy can neither be created, energy can neither be created nor be destroyed in a chemical reaction. Energy can only be changed from one form to another. We can see we are converting the kinetic energy present in water to electrical energy. Then electrical energy is converted into light energy, mechanical energy and other energies. But we cannot produce energy or we cannot destroy energy. So third point is that total energy is always constant. Total energy of the universe is always constant. Total energy of the universe is always constant. Now, our last point is that it is impossible to make a perpetual machine which will work forever without consumption of energy. So for anything, if even also I am working here, I am talking with you, for that I need energy and for that I am taking food. and your vehicle requires petrol, diesel, kerosene as a fuel. So everything requires a energy, and that it is saying that we cannot make any device that will work forever without consumption of any energy. That is all about the first law of thermodynamics.